All right, so this is looking at the first law of thermodynamics, which states that energy is conserved and cannot be created or destroyed. So the idea is really that energy is just transformed into different forms. So it might go from being mechanical to heat, or it might go from chemical to mechanical or to kinetic. So it's all about just transforming energy. And the key idea here with the first law of thermodynamics is the rule. So we need to know this rule. It's actually written here. I'm just going to write it to the side so it's a bit clearer. Delta U equals Q take W. Now Q is energy applied to the system that we're looking at, and W is work done by that system, and U is the change in the internal energy of the system. So you can consider Q and W as having different signs, okay, positive or negative, depending on what's going on. So you can see at the bottom here, you've got a little guide. So for example, if the system is absorbing heat, let's say energy from sunlight, what that would mean is that Q, which is energy being applied to the system, that would increase. So this is really thinking about, energy going in and out of the system, this Q. So Q would be positive if you've got energy going from perhaps sunlight. If the system is releasing heat, like when you sweat, Q is negative. That's because you're losing energy out here for Q. The next part is work. So if the system does work on the surroundings, like for example, if a hot balloon expands, it's doing things to the surroundings because you've got, an expansion in the particles in that balloon, then work will be, W will be positive. And the reason for that is we're losing energy out of our system. So by making this W positive, that means that you're going to subtract an amount. Okay, so if this was a negative, the W, then you'd be adding something. And that happens when the surroundings do work on the system. So for example, pumping up tyres, okay, your W is going to be negative because you're actually adding energy into the system. So that's negative. So the idea with the next question we're going to look at is we're going to use this rule and just think about what the signs are going to be for Q and W. So the first question we've got is a balloon is placed in direct sunlight. There's my little balloon. And we've got the sunlight applying 200 joules of energy to the balloon. So we've got 200 joules of energy going in. The air inside pushes out the balloon surface, doing 50 joules of work. So we've got 50 joules of work going on. So we've identified here a couple of things. First one is that this is going to be Q and this is W. Now it's asking us by how much does the internal energy of the air inside the balloon change. So remember that delta U equals Q take W. Now when we think about what's happening here, we've got energy going into the system. So because the energy is going into the system, this is really a positive. Okay. So we've got sunlight supplying that energy. When we think about the air inside pushing out, we've actually got work being done by the balloon. So that means we're losing some energy in the pushing out of that system. So this W here, even though we think of this as being like a negative, it will become negative, but we think of the W as being positive because it's positive work being done. We're not having work done to the balloon is doing something, it's being positive, doing some work. So now when we put these values in, we're going to have delta U, so the change in internal temperature, energy I should say, of the balloon is Q, which is 200, it's positive, minus 50 because it's positive. So can you see if this was a negative here, this would end up being adding energy, which is not what we're doing. So we've got 200 take away 50, which is 150, and remember this was in joules, so it's 150 joules. The next question we've got is B. So we've got, while doing some heavy lifting, so I've got a person with some very long arms doing some lifting of a ball. You do 2,500 joules of work on the weights, I'll make them 2 weights, while releasing 3,000 joules of heat. So if we think of it as a diagram, we've got heat coming out, 3,000 joules of that energy, and you're doing work on the weights. So the work that you're doing on the weights is energy that you're effectively losing. So you're losing or using energy through work, which is 2500 joules. So it's the same kind of situation as here, except here we've got energy going out instead of in from sunlight. So again, we've got change in internal energy. Now this is internal energy for U. So it's delta U equals Q, take W. In this case, Q is actually going out. You're losing energy. So the Q here, and I'll just do this in another colour. This is Q. Q is actually negative. We are losing energy, 3,000 joules of it. And the work, well, we're actually doing work again. So that means we're going to subtract even more energy. So the W here is a positive. So we're going to have minus the positive, which is this work that we're doing, which effectively ends up subtracting energy. So altogether we have negative 5,500 joules of energy. So our internal energy has decreased by 5,500 joules of energy, or if you wanted to, negative 5.5 kilojoules of energy. And that's because we've actually done two things. We've both been sweating and we've been doing or using energy to lift those weights. So that's the idea of the first law of thermodynamics, and the very important law that we have, which is delta U equals Q take W.